Hi, this is Miss Fig, and today's October 28th. Your test is tomorrow, so I'm going to be working on the test review. Remember that this test is cumulative, so it is going to have everything from this 6 weeks. So I'm going to be doing all the evens, and y'all will do the odds, and then all the answers are posted on Canvas with this downloadable file, so that way you can check if your answers are correct on the odd numbers. So we're going to start with number 2. List the transformations from the quadratic parent function. So the quadratic parent function is y equals x squared. And so we're looking at all the differences. So this first thing here, this right here, and this right here. So my first transformation is that 1/2, and a fraction makes my graph wider, so that's a vertical compression. By a factor of 1/2. My second change that I see is that -4. Remember, always on the inside, we're going to do the opposite. So that's a horizontal shift or translation to the right 4 units. And then that last change that I see is that -3 on the end, and on the outside we take it as it is. So that is a vertical shift or translation down 3 units. So now on number 4, y equals negative x minus 2 squared minus 3. I see a change here, here, and here. So that's 3 changes. Again, like I said in the transformations video, you don't have to write them in any specific order. I just like to write them in the order that they occur. But you wouldn't be wrong if you wrote the last one first or the middle one first. It doesn't matter the order that you write them in. So with that first one, we have the minus sign, and a minus in the front is going to be a reflection across the x-axis. Then the second change that I see is that -2 on the inside. Inside we think opposite, so that's a horizontal shift to the right. And then the third thing that I see is that -3, which is a vertical shift or translation. And that's down because we take it as it is, 3 units. Then on number 6, we don't have a change in the front. So there's not going to be a reflection, there's not going to be a compression, there's not going to be a stretch, sorry. So we have something here and something here. So the first thing that I see is that +1. So horizontal shift, opposite, so left 1 unit, and then 2, a vertical shift down 2 units. Those are the only 2 changes that I have. So then we are done on the transformations section. Again, y'all will be doing the odds, so 1, 3, and 5 are for you to do, but remember there are the answers posted, that way you can check. Now we're going to sketch a graph of these quadratics and list the vertex and the axis of symmetry. So to get the axis of symmetry, we're using x equals -b over 2a. A is 2, b is 12, and c is 15. So remember, we have y equals ax squared plus bx plus c when we're working with standard form. So for, oh, I'm sorry, that's the odd. For number 8, we have a equals -1, b equals 4, and c equals -5. So we're going to use that formula, x equals -b over 2a. So x equals -4 over 2 times -1, which is -4 over -2. So x equals a +2. That's my axis of symmetry. For the vertex, we're going to plug that back in to get our y value. So we have -x squared plus 4 times x minus 5. So y equals -4 plus 8 minus 5. Y equals 4 minus 5. Y equals -1. So that means my vertex occurs at 2, -1. So 2, -1 is my vertex. Since it is negative, this is going to be facing downward. And then x equals 2 is my axis of symmetry. And so in order to sketch this, I'm going to find two other points. I'm going to plug in when x is 1 and then when x is 0. So when x is 0, that's going to be the easiest because remember we've got y equals -x squared, so that'd be 0, plus 4 times x, that'd be 0, and then minus 5. So when we plug in a 0, it's going to cancel out those first two. So we end up with 0, -5 as a point. So down here. And then when x is 1, y equals -x squared plus 4 times x minus 5. So we're just plugging in a 1 instead of an x. So that's y equals -1 plus 4 minus 5. So y equals -6 plus 4, which is -2. So we would have a point 1, -2. Just go ahead and graph that point. So now we have the left side of our quadratic function, and remember that when we graph them, we are just going to reflect across that axis of symmetry. So I'm going to have a point here, and I'm going to have a point here, and then I just sketch that out. So I found my vertex, I found my axis of symmetry, and I sketched the graph. So then we're going to do number 10. It's the same type of problem. So these are in standard form. So my axis of symmetry is x equals -b over 2a. So my a is -2, b is -12, and c is -21. So to find my axis of symmetry, x equals -b, so -12 over 2a. And I'm going to distribute all those negatives, multiply on the bottom. So -12 is a +12. Two negatives will cancel. And then 2 times -2 is -4. 12 divided by -4 is -3. So that's where my axis of symmetry is. So if you want to go ahead and make that dotted line. And then to find the y value of the vertex, we'll plug in -3. So y equals -2, -3 squared, minus 12 times -3, minus 21. Y equals -2 times 9, +9, because remember a square is taking the same number multiplying by itself. So -3 times -3 gives me a +9, plus 36 minus 21. Y equals negative 18 plus 36 minus 21. Y equals 18 minus 21. Y equals negative 3. So I would have a point at negative 3, negative 3. So here is my vertex. Since it is negative, it's going to be facing downward. So I need to find two other points on either side. I'm going to go with the smaller numbers, so I'm going to find the points on the left. So I'm going to plug in a negative 2 and a negative 1 and see what I get. So negative 2, we've got y equals negative 2 squared minus 12, negative 2 minus 21. Y equals negative 2. Negative 2 squared, again, we would have negative 2 times negative 2. Two negatives make a positive, so we have a 4 in here. And then plus 24 minus 21. Y equals negative 8 plus 24 minus 21. Y equals negative 29 plus 24. Oops. And y equals negative 5. So we would have a point, negative 2, negative 5. Go ahead and graph that. And let's find a third point. So y equals, I'm going to plug in a negative 1. Negative 2 times negative 1 squared minus 12 times negative 1 minus 21. Y equals negative 2 times 1 minus negative 12 times negative 1 will make it a positive 12 minus 21. Y equals negative 2 plus 12 minus 21. Y equals negative 23 plus 12. Y equals negative 11. So we would have a point, negative 1, negative 11. So we'll go down all the way to negative 11. And so we'll reflect these points across that axis of symmetry. And then sketch out this graph. So my axis of symmetry is here, and my vertex is there. In this next section, we're sketching the solution to systems of inequalities. So that's where we are shading parts of the graph. So we have y is less than x plus 2, and y is less than negative 1/3 x minus 2. So these are in slope-intercept form, so that means we have the m and we have the b already. So for this first one, I would have a line that starts at 2, and then we have a slope of 1, so up 1 over 1, and then I'll just extend that to the left. So that's my first one, and since it does not have that line underneath, this is going to be a dotted line, and it is going to be shaded underneath since it is left. So we have a dotted line that is shaded underneath. Let's use this one. And then for the second one, we have minus 2 for my y-intercept. And then we have a slope of negative 1/3, so we'll go down and to the right 3. And then so we'll do the opposite, up to the right, to the left, sorry. And this is without that line underneath, so it is also a dotted line. And it is less than, so it's also going to be underneath. So we have a dotted line here, and we're shading underneath that dotted line. So then our set of solutions is right there in that double shaded area. So that would be our solution set right here. So we'll do another one, number 14. We have a line that starts at -2. And when I say starts, I don't mean that we're only to the left or to the right of that y-intercept. I mean that when I'm graphing it, I'm going to start graphing by going to the y-intercept of -2. And then we have a slope of 1/2, so we'll go up 1 to the right 2. And to go to the left of that y-intercept, we'll go down 1 to the left 2. No line underneath, so this is a dotted line. And it is less than, so we're going to be to the left of or underneath. So we'll draw in our dotted line. We'll shade underneath. For that second line, we're going to start at +2. And we have a slope of 5/2, so we'll go up 5. And we can't because it goes off the graph, so let's go down 5. 1, 2, 3, 4, 5. And then to the left 2. So we have a steep line. Oops, it has a line underneath, so it is a solid line. And it's still less, so it's underneath. So we're going to have a solid line. And we're shading underneath that line. So everything that is less than that line. So everything here. And so our solution set is only the parts that are double shaded. So my solution set does not include this part or this part. So my solution set is just right here. Now on number 16, we have a 3-variable system and we have 3 equations. It says solve each system. So in order to solve these, we can use substitution, we can use elimination. I'm going to find the easiest one to solve. So obviously the easiest one to solve would be z equals 1. I already know that z is 1, so I'm going to plug that into either equation. I'm going to number these. So I'm going to plug in 2, 1. Well, I'll be more specific. Plug 3 into 1. So we have -6x plus 2y minus 1 equals 27. -6x plus 2y. And let's add that 1 to the other side, equals 28. So we'll just leave that the way that it is. We'll solve that for y. So we'll add 6x, and we get 2y equals 6x plus 28. I still need that to be equal to just y, so I'll divide out that 2. Y equals 3x plus 14. So now I have y in terms of x, and I know what z is already, so I'm going to plug this new equation, let's call it 4. Let's plug 4 and 3 into 2. So instead of writing y, I'm going to be writing 3x plus 14. Instead of writing z, I'm going to write a 1. So negative 3x plus 2 times 3x plus 14, that's the y, plus 6 times 1, that's my z, equals 25. Negative 3x, distribute that 2, plus 6x plus 28 plus 6 equals 25. Combine any like terms. We have negative 3x plus 6x, which is 3x, plus 28 plus 6, which is 34, equals 25. We'll subtract 34 from 25. We get 3x equals negative 9. Divide by 3, and x equals negative 3. So now I'm going to plug that into my y in terms of x. So plug into 4. So y equals 3 times negative 3 plus 14. Y equals negative 9 plus 14. Y equals 5. So they gave us what z was. I found what x was. I found what y was. So my final solution we write as x, y, z. My final solution is negative 3, 5, 1. Alright, so on number 18, we have y plus 4z equals 23, 3x minus 6z equals negative 30, and 6x minus 3y minus 2z equals negative 19. So none of them are solved for like we had in 16, so we're going to have to solve one of them. I'm going to actually solve two of them because I see that here there is no x, and here there is no y. So I can get both of these in terms of z, and then plug them both in to the third one. So let me show you what I mean. So I'm going to solve the first one for y. So y plus 4z is equal to 23. Subtract that 4z so I get y by itself. And y equals negative 4z plus 23. Then I'll solve 2 for x. I have 3x minus 6z is equal to negative 30. I'm going to add that 6z to the other side. So we get 3x is equal to 6z minus 30. Divide everything by 3. And we get x equals 2z minus 10. So I'm going to say that this is equation number 4, and this is equation number 5. So then we'll plug 4 and 5 into 3. So 6, instead of x, I have 2z minus 10, minus 3, instead of y, I have negative 4z plus 23, minus 2z equals negative 19. Distribute that 6, and I get 12z minus 60. Distribute that negative 3, I get plus 12z minus 69, minus 2z equals negative 19. Combine on my like terms. So I see that I have all z's here, which is exactly what I wanted. So 12z plus 12z is 24z, minus 2z is 22z, minus 60 minus 69 equals negative 19. Add that 69. And I could combine the 60 and the 69, but I know negative 19 plus 69 is 50. So that's just how my brain did it since I'm not using a calculator. And then I'll add 60 to both sides. So 22z equals 110. Divide out that 22. And we get that z equals 5. So now I have what z equals. And I wrote both of my other variables in terms of z. So I'm going to plug z into 4. So I get y equals negative 4 times 5 plus 23. Y equals negative 20 plus 23. Y equals 3. And I'm going to plug z into 5, which is my equation for x. X equals 2 times 5 minus 10. X equals 10 minus 10. X equals 0. So I have x, y, and z. So my final answer, we write as x, comma, y, comma, z. So 0, 3, 5. So let's go to the next page. So here we want to solve systems by graphing. So these are two variable systems, two equations. Do number 20. So before, when we were solving the inequality systems by graphing, our answer is a solution set. So it's a set of points in the shaded area. When we're solving systems of equations, not inequalities, by graphing, our solution is going to be the point of intersection. So solution, point of intersection. So these are in in slope intercept form. So we'd have 1/3 x plus 2. It means I'm starting at positive 2. And I have a slope of 1/3, so I'll go up 1 and over 3. I can't go any further, so I'm going to do the opposite to go on the left of that intercept. So down 1 and to the right 3. Oops, I just said it the opposite way. We're going to go to the left, sorry. First to the right, then to the left, so we can go the opposite. And we get that line. So then for my second line, I have y equals negative x plus, what is wrong with me? Y equals negative x minus 2. So we're starting at a negative 2, and we have a slope of negative 1. So we'll go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And then to make points on the left, we're going to go up 1 to the left 1. So you just do the opposite. Oop, I see my point of intersection. These two lines met right here. So my final answer is the point negative 3, 1. Alright, so on number 18, it says solve each system by elimination. So that means we want to get one of our variables to cancel out. So we're going to multiply one of our equations by some constant to make it cancel out one of the variables. So I have 8x minus 5y equals negative 21, and x plus y equals negative 14. So I'm going to multiply either of these. I'm going to multiply the bottom one by negative 8 to make the x's cancel out. So keep the top one the same. 8x minus 5y equals negative 21. And the bottom one now becomes negative 8x minus 8y equals, and then negative 8 times negative 14, let's see, is 112. So these two cancel. Negative 5y minus 8y is 13y, negative 13. And then negative 21 plus 112 is 91. So then we're going to divide by negative 13. We get y equals negative 7. And then we'll plug that back into either of the equations. I'm going to use the one with smaller coefficients. So x plus negative 7 equals negative 14. So x minus 7 equals negative 14. Add 7 to both sides. And x equals negative 7. So my point of intersection, my solution is negative 7, negative 7. And then on that bottom one, 24, it says solve each system by substitution, where we want to plug one in and get it in terms of the other. So I'm going to solve the bottom one for y, since it would be a positive y already. If I solve the top one for x, I would have to divide by a negative, which is completely up to you what you do. I just like to go for the easiest route. So I see that that y is almost solved for. My pen's going crazy. So we have negative 8 plus 8y equals 22, and negative 2x plus y equals negative 1, so negative 2x plus y equals negative 1. I'm going to solve it for y, so I'll add 2x. Y equals positive 2x minus 1. So now I have that in terms of x, so I'll plug it into the first equation. So negative x plus 8 times 2x minus 1 equals 22. Negative x, and then we'll distribute that 8. So plus 16x minus 8 equals 22. Combine any like terms, we have 15x's now, minus 8 equals 22. Add 8 to both sides, we get 15x equals 30. Divide by 15, and x equals 2. So now we have to plug that back into my y equals equation, since we still have y in terms of x. So y equals 2 times 2 minus 1. Y equals 4 minus 1. Y equals 3. So my solution would be 2, 3. So for the test tomorrow, you need to work on all of the odds on this review. So there's 12 problems for you to do. And then make sure that you know each of the methods for solving our systems. Make sure you know how to solve 3 variable systems, and then make sure you know your parts of those quadratics, the axis of symmetry, the vertex, and your transformations on those quadratics. And if you can complete the other half of this review, then you are good to go for that test tomorrow. Make sure that you turn it in when it is complete.